Hi everyone, my name is Sathana. Welcome back to my YouTube channel, and you're looking at Math Help Sessions. In today's video, we're going to be looking at prime factorization, what exactly it is, and some examples as well, so that you can get some practice on how to use prime factorization. To start off, let's define. Prime factorization is a process that we use to write a number as a product of its prime numbers. And the key word here is prime numbers. What exactly does that mean? Let's take a look. A prime number is a number whose only factors, and here factors means numbers it can be divided by, are 1 and itself. So in order to explain that a little bit better, let's take a look at all of the prime numbers from 1 to 100. There's this little chart here that I've created, and each row here is a set of every 10, just so that you can visually see all of the prime numbers. And in order to better explain what a prime number is, let's just take an example. So in this case, let's look at 3. Let's say I want to divide 3 by a whole number in order to get a whole number. I can divide 3 by 3, which is 1. I can't divide 3 by 2, and I can also divide 3 by 1, which gives me 3. In this case, the only two numbers that I can divide 3 by are 1 and 3, so 1 in itself. That makes this a prime number. Let's look at another example. 13. I can divide 13 by 13, which gives me 1. I can't divide 13 by 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, or 2. But I can also divide 13 by 1 to give me 13. So 13 is also a prime number. So let's take an example of what, let's use an example to discover how to use prime factorization. So in this video, I'm going to show you two different methods. First method I call factor trees. Let's take a look at it with an example. So in this case, first example says to find prime factorization of the number 12. And so when you're using factor trees, it's a really easy method if you're able to quickly identify two numbers that multiply to make up the number you're looking for. So in this case, we have the number 12. For me, when I think of the number 12, the two numbers that I think of that easily multiply 12 are 3 and 4. So I'm going to split up this 12 into 3 and 4. 3 we have seen before. We have seen it on the list of prime numbers from 1 to 100. So we know that 3 is a prime number, but 4 is not on the list. That means 4 isn't a prime number. However, I know that 4 can be divided into two numbers, 2 and 2. So I can split 4 into 2 and 2. And 2 is a prime number. So that means that these are the three prime numbers that I can multiply to get to 12. So that's how you use the factor tree method to find the prime factorization. There's also a second method that I like to use to learn or talk about prime factorization, and it's not really long division, but I call it long division because it kind of looks like that. And what you're going to do is you're going to start with the number that you're given, in this case 12, and you're going to continuously divide it by prime numbers. It doesn't have to be the biggest number, just any prime number until you can get to 1. So in this case, I see 12 and I know for sure, okay, 12 is divisible by 3 and 3 is a prime number. So I'm going to divide 12 by 3 and it gets me to 4. So I need to keep dividing 4, and I can divide 4 by 2. So I'm going to divide 4 by 2 and it gets me to 2. 2 also isn't 1, so I'm going to keep dividing. I can divide 2 by 2 and I get to 1. Once I get to 1, I know that I'm done with this chain. And the end results are that these numbers on the left-hand side are going to be the prime numbers that make up your original number. Now, when we're done with prime factorization, we like to kind of write it out so that we can visually see it. And so what we do is we write the original number, the equal sign, and we list out all the numbers and we put the multiplication sign in the middle. And one key rule to note is that you always want to list them from the smallest prime number to the biggest. So in this case, 3 is the biggest number, so you put it at the end and you put the two 2's in front. In certain cases, you might have repetition of prime numbers. So in this case, we have 2 2's. And in order for elegance, in order to make it more concise, we can combine these two 2's and rewrite this as 2 squared. How we get that is the 2 is the base. However, this 2 comes because we have two 2's. If we had 3 3's, we rewrite this as 3 to the exponent of 3. Or if we had 4 7's, we would write 7 to the exponent of 4. So hopefully that kind of made sense. Now we're going to look at another example. This example says to find the prime factorization of the number 60. So for this example, I'm going to be using the factor tree method because I find that that's a little bit easier for me. We're going to start off with our number 60. And I know that I can split 60 into two numbers such as 6 and 10. So on this branch, I'm going to write 10. And on this branch, I'm going to write 6. Now I know that 6 and 10 are both not prime numbers. So I can further divide this. I can divide this 10 into 2 times 5. So I can write this as 2 and 5. And I can also write 6 as 2 times 3. And I know that 2, 3, and 5 are all prime numbers. So that means these are going to be my 4 prime numbers that will multiply to 60. And if you want to write this in that concise method, we're going to write it with 60. And we're going to list our numbers from smallest to greatest. So it's equal to 2 times 2 times 3 times 5. And again, we can see here that there's a repetition of prime numbers. So we can rewrite this as 2 to the exponent of 2 times 3 times 5. Let's take a look at example number 3. This is to find the prime factorization of 168. I'm going to leave you to solve this. I'm going to ask you to pause the video, try it out using whichever method you prefer, and come back to the video to compare answers. So hopefully you've done that, and we're going to be taking up the answer now. So for this example, I'll do the long division method. We're going to start off with the 168, and we're going to do our little long division sign, but the other way around. And I know that 168, even though it's a big number, it ends in 8. So it means I know it's divisible by 2. So let's write this 2 here. And if I divide 168 by 2, I get 84. Again, I know that 84 is divisible by 2 because it ends in an even number. So let's divide it by 2, and we get 42. Again, 42 is an even number, so I know I can divide it by 2. And this time I get 21. So this is a little different because I don't know it's even. But I do know that 21 is divisible by 3. So if I divide 21 by 3, I get 7. I know that 7 is a prime number, so I know that this is coming to the end. So I'm going to divide this 7 by 7 again, and I get 1. So now that I got to 1, I know that I'm fully done with this chain, and I know that this is my list of numbers that are prime numbers that multiply to 168. So now let's write this out. 168 is equal to 2 times 2 times 2 times 3 times 7. And if I want to write this in a more concise manner, I have 3 2's here. So I can rewrite this as 2 to the exponent of 3. And this 3 comes because I have 3 2's here. Multiply that by 3, multiply by 7. So this is my final concise manner. We have one last example. And it's to find the prime factorization of 100. Again, I'm going to ask you to pause this video, try it out on your own with whatever method you think is best for you, and come back and compare answers. Hopefully you're back. This time, I'm going to use the factor tree method just because that's the one that I find is easier for me. So let's start off with 100. I know that 100 is 10 times 10, so I can split this up into 2 10s. However, 10 is not a prime number, and I know that I can split the 10 into 2 times 5 because 2 times 5 equals 10. And I can do that for both of these. So 5 and 2, 5 and 2. And I know that 2 and 5 are both prime numbers. So I know that these are going to be my 4 prime numbers that when I multiply will get me to 100. So if I wanted to write this out, it would be 100 is equal to 2 times 2 times 5 times 5, because we always want to list from smallest number to biggest number when we're able to group these. So here I can group these two 2's together. So if I do that, I get 2 to the exponent of 2. However, I can also group these two 5's together. So I can write 5 to the exponent of 2. 5 because that's the number that we're multiplying, and 2 because there's 2 5's. Now I know that 100 is equal to 2 squared times 5 squared. And that's the end of this video. To recap, today we talked about prime factorization. Prime factorization is a process we use to write a number as a product of its prime numbers. And what are prime numbers? Numbers that can only be divided by 1 in itself. Here's a quick chart of the numbers from 1 to 100 if you ever want to screenshot it, just for reference. And the two methods that we use to calculate prime factorization are one-factor trees, where you take the number and you split it into two numbers and multiply into the original number, and you keep breaking it apart until you get to only prime numbers. The second method is to use long division, where you start with the original number and you divide only by prime numbers until you get to the end result of 1, and all these numbers on the side are going to be your prime numbers. And we went through 3 different examples. So hopefully by the end of this video, you've now understood prime factorization a little bit better. And I hope that this video has also introduced you to 2 different ways you can calculate prime factorization, and that one of these will be the method that you use. And I also hope to see you in a future video.